Dr. Mark Changizi here with your Science Moment. Today we're going to talk about why fireworks are so special and perceptually interesting. Why do people like fireworks? Now, they are definitely, there's a number of things that pop into mind. They're bright, they're loud, there's a lot of stuff like this. But there's some subtle aspects to them that I have partially noticed in the past. And just last night, it really occurred to me that there's more to it than even that. Now, one thing that has occurred to me for many years was that when you're watching fireworks, now, fireworks explode in a ball. That is, they're going in all directions in the sphere, right? It's not like it's directed just in a hemisphere in one half of the direction. They're in a perfect sphere. Poof, it pops up in all directions. But when you're watching fireworks, if you pay attention, you'll notice that it appears that each of the little flowers that explodes is coming toward you. You know that they're going in all directions, and occasionally, barely, maybe 1% of the time, I can get my brain to really believe that I'm seeing it going in all three dimensions. But almost never can I see it that way. I see it as all coming toward me. Now, first, an interesting part of that, first of all, that's interesting all by itself. So that's sort of an illusion, right? And one kind of perceptual or experiential part of that means that, well, if I'm believing, I'm perceiving, not believing, it was all unconscious, I'm perceiving it to be in the hemisphere that's towards me rather than the hemisphere that is away, there's a sense in which my brain is implicitly believing that I'm in just the right position watching this, right? Because someone over there would be seeing it all moving sideways toward me, right? And someone on the other side would be seeing it moving away from them, and that might not look as good as coming toward them. But of course, it's the same for everybody. But this is a sense in which we all feel like we're in a privileged position. Again, not consciously, but this is something that ends up that way because of this illusion. Now, another part of this that it occurred to me over the last 24 hours, what makes fireworks so exciting is that in real life, things don't grow in size much. You can have things that suddenly maybe get a little bit bigger. They typically get bigger slowly. But if something is growing in visual angle, that is, the visual amount of your visual field that it's filling up is suddenly expanding, right? That's not because, my hand can slowly expand, let's say, or can quickly expand, but for the most part, things don't suddenly expand from a very small thing and suddenly fill half of your visual field. The things that do go from small to filling a huge portion of your visual field are things that are moving towards you. They're looming towards you. So if I take my finger, right, and I go like this, well, now, in a very short period of time, I can go from tiny to filling up much of your visual field. And the faster that looming happens, the more that it's suddenly expanding, the more something is looming at you, coming directly toward you, which is dangerous and exciting. And you back up, you're like, whoa, look at that, right? I think one of the many dimensions for why fireworks are so interesting is that when they explode, right? This is something you haven't really evolved to see. You didn't evolve to see explosions and accommodate the fact that they're three-dimensional explosion. That's not anything that happens in normal life. And when it happens fast, the best explanation is that it's something coming directly toward you. Some really fast object coming toward you, looming right towards your eyes, right? And when those things explode and they fill a big portion of your visual field, especially when you're close enough that it fills a lot of your visual field, I think that your perception is instead of some group of, fire in some sense, all directly, like a train directly towards you, filling your visual field. This is why you back up and why it's so exciting. It really feels like it's directed quickly, it's directed exactly toward you. Everybody feels it's coming directly towards them individually, and they feel like it's all about them, and things are targeting them and going very quickly in lightning speed in some sense towards them. And that's the only way you can explain how something way over there, because I can tell roughly where it's coming out, can get almost to me, so it's filling all my visual field so quickly. It has to be something that's moving very dangerously quickly toward me. I think that's part of the fun of it. And so you can see here in the background, I've been showing just the standard stimulus. And when you actually look at this, sure, it's a lot like fireworks explosion, but it's also like something else, like when in Star Trek, when they go into warp, it's exactly the same kind of thing. And in Star Trek, it's a lot of stationary objects that are not moving relative to one another. They're not moving outwards physically from one another. They're all just moving toward the ship. And in this case, the ship is moving toward them and passing through them. It's the same kind of experience, and it's the much more probable interpretation of the kind of stimulus that you're getting when you're seeing fireworks, because we don't have experience in normal life with these sorts of explosions. We don't have experience evolutionarily for having mechanisms that are designed to see it that way. We're expecting them to be things that are moving forward, is the most common explanation for why you would have a burst of an illusion, a burst of stimuli like that. And in fact, it's exactly stimuli like that which explains why we see illusions, right? The classical geometrical illusions. And I have a TED talk on this that I'll just point you to in the description, and just a clip, a little bit here. You can see why we see geometrical illusions is all due to these kinds of flowing lines, because they're not just happening when there's something approaching me, they're happening all the time when you're moving, because all the time that we move, we end up with optic flow that's bursting outwards in our visual field. As it gets closer, it flows outwards quickly in your visual field. These are just exaggerated, highly colorful, and they're going from really small to really big in your visual field, suggesting some magical, luminary, colorful, sparkly thing, as a magician would. But it's not just being thrown into the air passively. No, it's being thrown directly at you like a train of fire. And that's why. But speaking of trains, here's a train which, had I been looking at it as it approached, it would have been somewhat looming. But of course, it's passing me, so it's totally safe. Its Doppler shift falls. It stops its growth. It doesn't have those properties that looming objects do. It doesn't have the properties that fireworks accidentally mimic. And it's what they accidentally mimic, which is often what selects for them and makes them continue as memes that continue in cultures. What people think is so exciting about them is that they go boom, is often not what makes them travel and spread from culture to culture. What really, I think, is making them spread is because it's accidentally mimicking the looming experience, the looming mechanisms that were designed to detect. And that was your science moment. If you're interested in these sorts of things, you can take a look at my earlier book, Vision Revolution, which is on many facets of why we see the way we do, the superpowers of vision that we have, all of these things concerning half a dozen or more discoveries of mine in the areas of visual perception, like why we see in color, why we see illusions, how we came to read despite not ever evolving to read, why your eyes face forward. All these theories that I have, which have been backed up considerably, are all not what you've heard of. They're all sort of the anti-Wikipedia theories. And that was your science moment.